Hi,
Hello,
I'm Nikhil.
I'm David.
We contribute to the development of sovereign software at Skip. What is programmable consensus? We view it as the universe of commitments that can be made between agents, users, operators, and your protocol itself, where the protocol acts as the enforcer of these commitments. And we briefly chat about some mechanisms for facilitating the propagation of these commitments between protocols. Before we actually start chatting about programmable consensus, it's useful that we have a shared understanding of agency and site in a protocol. Agency we define as what your protocol can enforce based on available inputs, as well as what it can attribute given these inputs. And then site specifically is what your protocol can observe as inputs and the level of introspection that it has into its own operation. An illustrative example of this is a validator equivocating via a double sign, right? So this validator has previously entered into a commitment considered credible with the protocol that it won't double sign. So at block H, its vote on block H is finalized. So the protocol only sees that vote. Everything seems fine. But at block H plus 1, some benevolent actor submits evidence of the validator's double sign. At this point, the validator has sight over this operator's equivocation, and they can attribute it to that validator by virtue of these votes being digitally signed. And the protocol has the ability to enforce equivocation because this validator has something at stake.
So, there's a general separation between like what your users, your operators, and your protocol can see. Your protocol effectively is aware of a state transition function. It knows of the inputs that are given to it. The operators are aware of each other, and they together provide inputs to the protocol itself. They also might be aware of relayers, block builders, or price feeds, and they might enter into private agreements with said service providers to essentially provide these new inputs to the protocol itself. And at the very outside level, you have your community, and they see everything from the outside in. They're able to observe the positive or negative externalities that come as a result of these private agreements that the operators make. And meaningfully, there is a principal agent problem that exists between the user, the operators, and then the operators in the protocol itself. The user and the operators may have principal agent problem based on how transactions are ordered, and then the protocol and the operators may have a principal agent problem based on the inputs that the operators themselves might be providing to the protocol itself. So we believe that programmable consensus exists on a spectrum that we broadly define into 4 different categories. First one is programmable state transition functions. These are Cosmos chains as they exist today. The second one are proposer enshrined middleware. So this is essentially extending APCI++, specifically prepare and process proposal. The third one is protocol enshrined middleware. And this is also extending APCI++, specifically vote extensions, so extend and verify vote. And then the final stage is called the fully programmable consensus.
This begs the question, what agency do we have over your proposers, right? Because the protocol has like little sight over what the operation of these external mechanisms is, but they meaningfully augment the behavior of the protocol, this is a risk to the protocol itself. Your community acts as the backstop to make these external actors accountable, right? They can identify certain negative externalities that exist as a result of these protocol operators existing independently of the protocol and potentially propose modifications to the protocol to hold them accountable. So in summary, protocols have limited agency. The result of this is that in order to modify your protocol, you need to directly modify your consensus. Sadly, this isn't a pretty long process, it takes a lot of time, and it's a pretty high context process, right? I need to be fully aware of the consensus engine and like the implications of any modifications I make to it. Because of the limited size of the protocol, operators have the ability to fill in the gaps with unaudited behavior that meaningfully augments the behavior of the protocol. And then finally, community organization influences protocol development, right? They identify where these misalignments exist and try to solve this principal agent problem by proposing meaningful modifications to the protocol to enshrine more of these unaccountable parties.
Okay, so how do we address the proposer monopoly? Well, essentially at this point we have we have the ability to essentially take some of these third parties that exist and enshrine them directly in the logic of the proposer. So this is what we're calling to be. This is what we're calling to be proposer enshrined middleware. And effectively, what happens now is operators are able to essentially execute this said middleware, specifically the proposers. But other operators cannot meaningfully contribute to what the proposer is doing. They can just make attestations. They can say yes or no, and that's more or less it. Proposers still have a monopoly over the inputs that can be provided to the protocol itself, and the community can be, retroactively asking for new middleware that the proposer can enshrine directly to allow for the protocol to have more agency and more sight. And you can think of this as something like ePBS or the block SDK or proposer-led oracles. And this begs the question, does the principal agent problem exist? Yes. And a good example of this, skip slides. Okay. You just control this. Yeah. Okay. Okay, so a good example of this, whether or not the principal agent problem exists, whether there is a proposer monopoly, yes. And a good example of this is the skip /dydx MEV dashboard, where we can essentially monitor the order books that each validator is maintaining and see whether or not certain proposers are censoring or reordering transactions to extract MEV. Skip. So at this point, protocols now have somewhat credible external inputs. The protocol has agency over the inputs that the proposer is providing through this said new middleware, and they are able to expand the sight of what they see via the proposer explicitly. However, this is gated by other operators. The operators are able to essentially hold each other accountable, specifically the proposer. However, the proposer still does have a monopoly, but they are somewhat more bounded by the protocol itself. Other operators can still enter into private agreements with third parties or private channels. And the community now essentially has more introspection to the outside world solely through the lens of the proposer. However, they are also able to effectively see any sort of misbehavior that a proposer might have with the specifically enshrined middleware.
Yeah. So this begs the question of how we actually remove these intermediaries and make these decentralized applications sovereign. The way that we're proposing that this happens is via protocol enshrined middleware. A mental model for this is Slinky. Essentially what happens now is that we delegate the responsibility of providing inputs to the middleware, to the protocol via vote extensions or some other mechanism, and we delegate the execution of this middleware to the protocol, right? At this stage, we no longer need to depend on intermediary signer sets to observe external information, provide some amount of credibility to it, and give it to our protocol. We can now enforce all of these rules directly in the protocol by increasing both the agency and sight of the protocol itself. Sadly, it's still reactive. If there is some external middleware, these operators still have the ability to enter into these commitments, and the community has to retroactively organize to enshrine these. So as a recap, protocols are now at the stage where they can operate middleware. As a result of this, centralized applications that depend on these inputs are sovereign. Next. Operators have the ability to equally contribute to the middleware's execution by providing their own input of the outside world. As a result of this mechanism, the community gains meaningful introspection into the inputs that every operator has given to the protocol, and they can attribute any false inputs, etc. Right? So at this point, the community has perfect attribution. A good example of this is that in MinScan now, every block proposed on DYDX mainnet has like a little tab that you can click into, which gives you a detailed input into exactly which proposers have proposed what price per block, right? In this case, the community has the ability to like introspect which proposers or which operators are giving inputs that are meaningfully different than what the protocol sees and what other operators are seeing.
We've taken the proposer monopoly, we've overthrown it. Now we have an operator oligarchy. And essentially now a chain can enshrine any critical portion of its supply chain in a economically and cryptographically secure way. All DApps that, as Nikhil mentioned, that rely on said middleware are now sovereign. However, development is still reactive. The community has to determine exactly what new middleware to introduce, how to introduce it, and it takes a very expansive amount of time to actually get to the point at which this actually can be a thing that developers use. So say, for example, I deploy a smart contract that relays my transactions from one chain, my protocol, to another chain. And I trust some subset of my validator set to be executing new middleware that specifically relays my transactions to the destination chains. Or say that I deployed a DAO and I need some other subset of my validator set to be running an NPC for secure and private voting for my DAO. Or say that I don't even care about the economic securities or guarantees of my validator sets or subset of my validator sets, and instead I rely on a reputation scheme for a prediction market that I deployed, and I need AI agents who have a lot of data to effectively interact with my DApp to sway prediction markets in the direction that they should effectively follow. So I essentially contract, and I make a commitment agreement with OpenAI to essentially just bombard the chain and my DApp to interact with my application. So now we're at the stage where we have fully programmable consensus. And the way this is implemented is essentially expressive, credible commitments as smart contracts. So you can imagine that a user effectively deploys a contract that defines the commitments that they want with the incentive structure that they want. They can define the operators that they want to be participating in said commitment. And this all becomes enforced by the protocol itself. So effectively now the bounds and sites of your protocol are essentially endless. There's no site and end, I guess. And we can now view all middleware as effectively a commitment that a user makes with any operator, whether it's your validator, whether it's something external to the network itself. That is all enforced by the protocol itself. So protocol development can be proactive. In general, Cosmos development is generally pretty reactive. So we'll experience a problem on the mainnet. We'll have to make a patch. We'll have to, for example, fee markets are a great example of this, where chains sometimes break because transaction ordering and fees are just not at the point that they should be. So what if users were effectively able to deploy fee markets as smart contracts that other validators can essentially run and execute via middleware that is subsetted amongst your validator set?
So now that we've defined rigorously what programmable consensus is, it begs the question, how do we build towards this, right? We can leverage new developments in ZK and credible commitment schemes and Byzantine fault-tolerant consensus to optimize our protocols for this architecture. In particularly, we can increase the scope of credible commitment devices. We can increase the efficiency and ubiquity of zero-knowledge proof schemes, both Snarks and Starks. And at the consensus layer, we can utilize Bullshark, Narwhal, consensus pipelining to optimize for the production of data and dissemination of it at the head of a blockchain. We can utilize data availability and erasure encoding for the same reason, optimize for liveness in asynchronous environments, and we can utilize heterogeneous consensus to actually propagate these commitments across multiple chains. In terms of gossip optimizations and P2P network overlays, we can utilize these to modularize the sidecars that exist to fulfill the commitments that we've deployed on our chains, and potentially share these across validators on multiple chains. Building on the point that I just talked about, let's say that I have a commitment to provide the ETH USD price feed to a perp that I've deployed on DYDX. And the operator set that I've enlisted for this commitment is also an operator set, part of the operator set on Osmosis. What I can do is I can enlist that same operator set to do the same thing they're doing for DYDX, but on Osmosis. And I can develop a positive sum economic security for the protocol as it exists on both chains. Right? One way, a mental model for this that I like is mesh secured smart contract inputs. Next slide. We can introduce network effects as a result of this by introducing reputation schemes that attributed to every validator within the Cosmos. In a lot of cases, operators do a lot of work that is external to the protocol, whether it be developing community software, helping with the development of proposals to direct protocol development, and a lot of these things are very rarely surface to the protocol, right? Via using reputation and awarding these validators for their contributions with a reputation scheme that can be enforced across multiple protocols, we can achieve network effects throughout the interchain. Finally, this scheme of parameter consensus, we believe, has the ability to turn blockchains built this way into superorganisms, right? Sovereign, infinite agency, boundless sight, driven by the collective intelligence of the community. That's it.
Yeah, so outside of Oracle feeds, what do you guys foresee as like external data that an app might require?
A good example of this could be like packet data or any relayer inputs, like client updates, etc. Right now, the protocol depends upon a relayer who's currently an unaccountable party. There are some proposals to enshrine these via incentive mechanisms into the protocols involved within this like IBC channel. But enshrining it at the protocol layer is like the best way to make this practice sovereign. So that's one example. Another example could be like consensus mempools, right? One of the products that we've built and deployed upon several networks in the Cosmos is like block SDK. But there's an actual downside to implementing this protocol, which exists across most proposer enshrined middleware, which is that the protocol has no introspection to the operation of this thing, right? If I have like an order matching engine that I'm running locally on every validator, that validator, as a result of the principal agent problem between itself and the protocol, you can't audit its behavior, right? Is it matching orders correctly? Is it providing some deference to a user that it has a relationship with? But if we provide these inputs directly to the protocol and let the protocol do the matching, we can actually get credible security over this like middleware.
Bridges is also a big one. Asset issuance in general.
All right, thank you.